Hello, today we are going to look at the conduction system of the heart. We are going to base mostly on the way action potentials are distributed all over the heart, from the from left atrium and the right atrium, as well as what left ventricles and and the right what ventricle. The heart as a pumping organ actually play a great role of ensuring that blood is transferred all over the body. Blood is what translocated or transported all over the body. And so long as blood composes of a lot of essential components such as what respiratory gases, oxygen is actually supplied to the body tissue. Oxygen is actually supplied to the body tissue, and the vice versa is true. Carbon dioxide from respiring cells actually is going to be transported from the body tissue by the aid of water pumping of the heart to the lungs. Not only respiratory gases, even nutrients is transported or distributed all over the body because of this sort pumping organ, the heart. So the heart has what different functions, a lot of functions that it play a great role to make sure that life is continuing. So the heart is very crucial organ within our body. Heart is very crucial organ within our body. So first of all, let us look at the parts of the heart. Let us look at the parts of the heart. The heart is divided into main three layers. The heart is divided into main three layers. We have the outermost part of the heart, the outermost part of the heart, the outermost part of the heart, known as epicardium layer. Epicardium layer. The epicardium layer has two components. We have the outermost layer of epicardium, known as outermost layer of epicardium that composed of simple squamous epithelial tissues, simple squamous epithelial tissue. From the outermost part of simple squamous epithelial tissues, the inner part, just beneath the simple squamous epithelial tissues, we have loose connective tissue. We have what loose connective tissue. This loose connective tissue composes of the adipose tissue, that play a great role of, first of all, supplying out energy as a source of energy, as well as playing part as the shock absorber, and outer part of the epicardium, there is what a pericardial fluid. There is what a pericardial fluid that reduces all friction. That's what reduces friction once contact with the outermost part of the heart, which is what epicardium. And so long as epicardium at the outermost part of it is composed of these sort of simple squamous epithelial tissue, so there is what a clear friction. There is what or the role of it is to ensure that friction is reduced. The role of it to ensure that the friction is reduced between the heart and the surrounding organs, between the heart and the surrounding organ. Then from epicardial layer of the heart, the middle layer of the heart is myocardium. The middle layer of the heart is the myocardium layer. Myocardium layer is the middle layer of the heart that composes of the um, cardiac muscle cells. And these cardiac muscle cells actually have a very large number of mitochondria, to ensure that energy is supplied at this part, because this part is the most part that concerned with contraction of the heart. So the cells at this myocardium layer, the cell at this myocardium layer composes of intercalated disc So intercalated disc actually provide the boundary between one cell and another, one cell and another. So within those intercalated discs, we have certain kind of gaps. We have what a lot of gaps. These gaps are known as gap junction. These gaps are known as gap junction. Allows distribution of action potential all over the myocardium. And this distribution of action potential actually play a great role to ensure that there is contraction, there is possibility of the heart to contract, and the contraction and the relaxation of this of the heart enabling um, pumping of blood outside of the heart through aorta and pulmonary artery. Then from the mid part of the heart, we move inside toward another layer of the heart known as endocardium. Endocardium is the innermost part of the heart. Endocardium is the innermost part of the heart. Endocardium is the innermost of the heart that is composes of the ridges or rough surface, which also covered by simple epithelial tissues known as squamous epithelial tissues. Simple epithelial tissues known as squamous epithelial tissues. But this layer of endocardium possesses certain kind of cells that secreting thrombo, thrombomodulin, thrombomodulin chemicals, thrombomodulin fluid, thrombomodulin fluid. These thrombomodulin fluids on the surface of endocardium. This is thrombomodulin fluid on the surface of endocardium play great role of preventing coagulation of blood as enters within the heart, preventing coagulation or clotting of the blood as enters within the heart. So this is generally um, types or layers of the heart, layer of the heart. The outermost layer of the heart is the epicardium. So epicardium actually bordered with pericardium fluid, pericardium fluid that covers outermost part of the heart and play a great role of preventing friction between the heart and the surrounding organs, between the heart and the surrounding organs. Now let us look at now let us look at the the conduction system of the heart. The conduction system of the heart actually starts from this portion known as the sinoatrial node. Starts from this location or points known as the sinoatrial node. Sinoatrial node is a pacemaker. Sinoatrial node is a pacemaker. The pacemaker means that it's the one that initiates action potential, is the one that initiates action potential. Once the blood from different part of the body, especially from inferior posterior vena cava as well as from the superior vena cava, once blood fills up the right atrium, as well as some of the blood from pulmonary veins, which carries oxygenated blood from the lungs and toward the heart through these pulmonary veins. Once blood is filled at the right auricle or right atrium and this left atrium, the sinoatrial node is going to initiate action potential, and actually this action potential spreads at the layer of the myocardium, spread at the layer of myocardium. As I was said just for previous, that the myocardium layer composes of millions of cells. These cells has intercalated disc, and on those intercalated discs, there are numerous gap junctions. And those gap junctions are playing great role of resisting, of preventing or the resistance of spreading of the action potential. So simply it means that those gap junctions allows spread of action potential from sinoatrial node, which is located at the right atrium. As you can see, these arrows towards the left atrium, and the sum of the action potentials is going to be spread towards another point known as atrioventricular node. The atrioventricular node, as you can see here, is going to pass through the septum. As you can see here again, there is what a left atrioventricular node at this point is going to divide into two parts, left and right. What the band of his again is going to undergo further subdivision at the bottom of the ventricle, at the bottom of left ventricle and right ventricle, and the enabling contraction of this ventricle, left ventricle and right ventricle, once the blood flow atrium, right, the right atrium and the left atrium, and produced towards right ventricle and left ventricle. Once here the tricuspid valves opens, blood is going to be poured inside, and once here bicuspid valves opens, then the blood is going to be poured at left ventricle. So the spread of action potential through, first of all, the band of his, starting from what is atrial node as a pacemaker, initiate the action potential toward atrioventricular node. Then from atrioventricular node, then the action potential again is going to be sent to the left and the right band of his. Then from what the band of his, this band of his, as you can see here, have been not distributed or divided further to form Purkinje fibers. These Purkinje fibers maximize the activity, the action of this action potential, ensuring that ventricle, left ventricle and right ventricle contracts. And then after being contract, then blood from right ventricle is going to be pumped toward the pulmonary artery and distributed also the oxygenated blood towards the left lung. And at the same time, this left ventricle is going to distribute oxygenated blood from the lungs that has been poured inside of the heart, through these pulmonary veins. Then the oxygenated blood will be distributed all over the body. It's going to distribute all over the body. So another function of the heart sometimes play a great role as an organ, an endocrine organ sometimes play a great role as an endocrine organ. Why? Because at this right atrium, once within our body there is an increase in blood osmotic pressure. Once within our body there is an increase in blood osmotic pressure, after this right atrium is going to secrete a certain kind of hormone known as adrenaline hormone. After being secreted, then this adrenaline hormone is going to be transported via general circulation up to the collecting ducts, ascending loop of handling, making sure that reabsorption of sodium is inhibited, and ensuring that most of what sodium ion is excreted through urine, and making sure that potassium ion increased within our body so as to lower the blood osmotic pressure. So to make sure that blood osmotic pressure is going to be lowered down. So thank you viewers for listening and make sure that you subscribe our video. Thank you for today.